Hi, Dr. Cap. Travis White-Velez back with this week's Advanced Concept Interactive presentation. For this week, we will be creating magnetic fluid. For this experiment, you will need toner. I will be accessing that out of a laser jet cartridge. You will need vegetable oil, and you will also need magnets. I'm gonna get the experiment together, and then I'm gonna come back and explain exactly what a magnetic fluid is and why the reaction that takes place happens. Stay tuned. Okay, I'm back and I've gathered my supplies. I have about 50 mLs of toner, which you can see in there. I have another container that I'm gonna mix everything in. I have the vegetable oil, so I'm going to pour the toner into this container. I'm then going to pour vegetable oil into this container. Give that a good mix. Almost. Gonna add a little bit more vegetable oil. Okay, now that's the appropriate consistency. And now I am going to get my magnet and we are going to watch what happens. Stand by. All right, I am back with the magnet now and we will watch what happens on the side of the container. And then just so you guys can see in the inside, not sure if you can see too well what actually happens. And now that I've conducted the experiment, I will clean this up and then I'm gonna come back and explain to you what this reaction is called and why it happened. Hi, Dr. Caps, and whoever else is watching. Now that I've completed the experiment and cleaned up a little bit, I will explain to you exactly what we saw take place and what a ferrofluid is. So a ferrofluid is a colloidal suspension of small magnetic particles that are suspended in fluid. In this case, the magnetic particles were in the toner, and the fluid that we utilized as our suspension was the vegetable oil. The vegetable oil in this case acts as a surfactant, which pretty much stops the particles from clumping together or sticking to themselves. They're more able to freely slide and move. Because the particles are magnetic, they are attracted to oppositely charged poles. So in this case, when we applied the magnet, we were able to see the fluid or the particles pull upwards. It showed bubbles in some presentations and some examples of ferrofluids, you'll see spikes. In my case, I saw bubbles and you could see the magnetic particles moving around the glass jar. Ferrofluids are actually utilized a lot in computers, hard drives, and in medicine, which I know a lot of us taking this class are interested in going into or furthering our careers in medicine. I was interested to find out that ferrofluid is actually used as the contrast dye for MRIs. An MRI essentially is a big magnet, and the ferrofluid is either injected or ingested prior to the study, and it is pulled in the area being imaged, and it gives you, more contrast to a specific area that's being studied. Ferrofluids are also important in, the study of NASA because they were actually invented in 1963 to be used as part of the fuel system for a rocket that would be launched into space. You would need a weightless fuel that would be able to be pulled upwards into the launching mechanism to propel the rocket forward while the rocket would be in space. So they utilized magnets and ferrofluids to make that happen. I hope I did a good job of explaining exactly what a ferrofluid is, and thank you for your time. Take care.